We're going to begin our discussion of probability and statistics with probability. And that's because statistics is based on probabilities. So let's talk about the idea of probability first. Probability is the measure of the likelihood of a phenomenon or chance behavior occurring. Probability deals with experiments that have random results, which we call outcomes. So anytime we talk about an outcome, we're just talking about some result from an experiment that happened randomly. And they're only random in the short term. In the long term, these outcomes are actually predictable. So, an experiment is a process with uncertain results that can be repeated. So think of an experiment as something like it could be flipping a coin or rolling a die or picking a name out of a hat. Any of those things we can do, and then we can repeat that action. So the results of any single trial cannot be predicted. If we flip a coin, we can't predict whether it's going to land on heads or tails. However, we can predict how many times it will do that, land on heads, over a large number of trials. And that's what we call the law of large numbers. So, most of you, I think, if I asked you what the chance you get a heads when you flip a coin, would tell me it's a 50% chance or 1/2. Because there's two sides to the coin. One has a head, one has a tail. And so one chance out of two that it lands on heads. So we can't predict when we flip that coin whether it's going to land on head or tails. But if we flip that coin 10,000 times, we can say about half of the time it's going to land on heads. And that's what the law of large numbers is about. So another way of stating the law of large numbers is as the number of trials of a probability experiment increases, so in other words, if we do more and more trials, the proportion at which a certain outcome is observed gets closer to the probability of the outcome. Okay, moving on. We have some definitions we need to fill in. So a sample space is the collection of all possible outcomes of a probability experiment. And we'll see an example here in a minute. An event is any collection of outcomes. An event can be one single outcome, or it could be more than one outcome. What we call a simple event is an event that has only one outcome. And we denote simple events using lowercase letters. With subscripts. So you might see little e1 or little e2. Regular events that are not simple events, we denote using uppercase, or we call them capital letters. And we usually say like E, or sometimes we say F. Or we could say A or B, it doesn't matter as long as it's a capital letter. One other thing we need to note is that the variable n we use for the total number of possible outcomes. Or later in the semester, we will use lowercase n to be the sample size. So let's see some examples of how this works. Sample spaces and events. Suppose we toss a coin twice. What is the sample space? Well, for a sample space, it's a set. And all sets, which are just collections of things, we use braces so that we know it's a set. So if we toss a coin, what outcomes do we have? Well, we either get a head or tails, right? So our sample space is H for head, T for tail, and then we close the brace. Okay, what about if we toss a coin 2 times? What is the sample space for that? And to figure this out, we are going to do something called a tree diagram. So we have our first toss. What can happen on the first toss? One of 2 things, right? Either we get a head or we get a tail. So if we get a head, we do our second toss. And what are the outcomes for the second toss? We could have either a head or we could have a tail. Okay, what happens if our first toss was a tail? Well, we still have to make a second toss. So when we make the second toss, what could happen? Well, when we toss it the second time, we could either get a head or a tail. So our sample space is all possible combinations of following the branches of this tree. So if we start here at the point that I just marked in blue, we could go this way and then to heads. Or we could go to heads and then to tails. So our sample space is going to look like this. Heads, heads. That's if we get a head both of the 2 times we toss it. We could get a head first and a tail on the second toss. We could get a tail first and a head on the second toss. Or we could get 2 tails. So that's our sample space. So number 2 says, let event E be getting 2 heads. And that means when we toss it twice. So event E would equal, now events are sets also, so they get curly braces. And if we look at the 4 options from our sample space, only one of them is an HH, and that's getting 2 heads. So HH would be our event E. Event F is getting 1 tails. So how many ways are there to get 1 tail? Well, we could either get a head first and a tail second, or we could get a tail first and a head second. So this time, our event has 2 options in it. Okay, we'll stop this video right there, and we'll pick up with my demonstration of the rock, paper, scissors activity in the next video.